Greetings, chemistry students. Mr. Resentis again. I'm on page 323, and this is chapter 10. I'm on the 10-2 mole conversion. By now you should already know what a mole is. In way of review, let's quickly talk about that. A mole is a grouping, agreed upon grouping, just like a gross is 144, a dozen is 12. A mole is 1 Avogadro's number, which is 6.02 times 10 to the 23rd, named after the Italian chemist Avogadro. A mole is also a mole of mass, which is the basically added together the masses within the formula. For example, I don't know, an example would be salt. Table salt is sodium, which we find is 23 plus chlorine, which is 35, and so we say that the mass is 58.5. So the mole could be grams, it could be particle number. It is an agreed upon grouping. So when we convert from grams to moles, let's say we want to find out 12 grams. 12 grams equals how many? 12 grams equals how many moles? All right, that's why the question mark is there. 12 grams equals how many moles? Well, we say 12 grams. 1 mole is 58.5 grams. And so, as you can see, what we have to do here is we have to divide. And the grams cancel out nicely for us, so the answer is 0.2 moles. So when we go from grams to moles, you divide by formula mass or by molar mass. Okay, so you divide by the molar mass. If we go from moles to grams, let's say that we have 3 moles is equal to how many grams? Okay, good question. Well, we just say 3 moles, 58.5 grams in 1 mole. We set our dimensional analysis up like this so that our moles cancel, and we have to multiply, and we say 175 grams. There are 3 moles equals, and here we're talking about salt, of course. There's 3 moles equals how many grams of salt, or NaCl. 12 grams of salt equals how many moles of salt? Right, NaCl. Alright, so we're talking about all of these. I neglected to add that I'm talking about salt. Alright, that's why it's 58. And so that's why you need the molar mass. Alright, so how about particles? We could say 3 moles of any substance really equals how many particles? Well, here what we would say is 3 moles is 6.02 times 10 to the 23rd, that's Avogadro's number, is 1 mole, because as I said that a mole is 1 Avogadro's number. All right, so here we would multiply, and as you can see here, we also multiply on this one. So if we're going from moles to grams, we multiply. When we're going from grams to moles, we divide. And when we go from moles to particles, we're going to multiply by Avogadro's number. So it's 1.8 times 10 to the 24th particles. All right. So, sorry, there's no A. So 3 moles, because 3 moles is 3 times 6.02 times 10 to the 23rd Avogadro's number, because 1 mole is 6.02 times 10 to the 23rd. All right. So from particles to moles, we're just doing the reverse now. We have to divide. So if we want to know, for example, 3.0 times 10 to the 24th particles equals how many moles, then in this situation, what we would do is set up our dimensional analysis like this. 24 particles. 1 mole is 6.02 times 10 to the 23rd particles, and we want our particles to cancel. We want to end with moles, and so that's why we set it up like this. And when you divide this, it comes out to be 5 moles. All right? Now, if we want to go from grams, let's say we want to go from grams to particles. We want to go from grams to particles. Notice we have to go through moles to get there. We have to go through moles to get there. All right? So let's try one of those. Remember, to go from grams to particles, you must find moles first. All right? So how many grams are 7.2 times 10 to the 22 atoms of calcium? All right, so I've changed. We're no longer talking about salt, we're talking about calcium. Well, remember, we have to go through moles. So the first thing we're going to do is we're going to take our 7.2 times 10 to the 22 atoms or particles, and we're going to turn those into moles, because 1 mole of calcium is 6.02 times 10 to the 23rd, right? And so that'll give us 0.12 moles, right? So all I did was I just divided. Now that I have my moles, I could take my moles, 0.12 moles, and set up my dimensional analysis so that I end in grams. So if I look on my periodic table, calcium's mass is 40.1 grams, and 1 mole is 40.1 grams. So all I have to do is multiply, and I end up with 4.8 grams of calcium. All right? So notice I had to go through moles before I got to grams, starting with particles. All right? Now, what about gas? What we've done so far is fine, but what gas is not measured in grams. It's measured in a volume. So we've got a bit of a kerfuffle. 1 mole of gas occupy the same volume as any other gas at STP. And STP is standard temperature and pressure. Standard temperature and pressure is 0 degrees C and 1 atmosphere. All right. So STP is just standard temperature and pressure. Well, and what that is 22.4 liters equals 1 molar volume. All right. Well, now that we have that number, 22.4 liters, we can now work a problem based on gas. So we have 1.0 liters. Here's our problem. 1.0 liters of 1.0 liters of carbon dioxide. Here's our gas. We're not going to be able to weigh it. We won't have grams, but volume is how many molecules. And of course, assume STP. I mean, this will only work if it's at standard temperature and pressure. Okay? Well, 1.0 liters, and we already said that 1 mole CO2, or any other gas for that matter, is 22.4 liters. So our liters drop out and we get moles, so that'll be 0.045 moles CO2. Now that we have moles, what we can do is we could take the moles then and turn those into particles or molecules. All we have to do is say 0.045 moles is 6.02 times 10 to the 23rd particles or molecules, and that is 1 mole, right? And so if we multiply, we get 2.7, let's see, 2 sig figs, yep, times 10 to the 22 particles or molecules, either one, particles or molecules. It's the same. I could write molecule here. Molecules of CO2. Okay, don't be annoyed that I used particle. All right. Let's try one more. Let's see if we can squeak one more in here. A reaction produces 0.82 moles of oxygen, O2. All right. What is the volume? And then assuming STP. Always assume STP. Well, 0.82 moles of O2 is 22.4 liters at 1 mole, and that'll give you 18 liters. All I did was multiply. All right?